Hello, my name is Evan Witz. This is Math 219, Multivariable Calculus. We're going to be working with the dot product today, and specifically we're going to be using it to find angles and projections of multiple vectors onto each other. So if you have any suggestions for problems, feel free to post on the forums, and we will try to get to your problems. Again, we can only do problems that aren't on your class activities, but if you have a problem in the book that you want us to do that's even similar to something that is on your activity, feel more than free to suggest it, and we'll give it a shot. So, yes. So, given these two vectors, v, which is equal to 2i hat plus 10j hat minus 11k hat, and w, which is equal to 2i hat plus 2j hat plus k hat, we're going to find a couple of different quantities. The vectors, the dot product of the two vectors, the magnitude of vector v, the magnitude of the vector w, the cosine of the angle between those two vectors, the component of vector w onto vector v, and the projection of vector w onto vector v. So at this time, if you want to pause the video and give it a shot, go ahead and do so now. And when you unpause the video, I will solve the problem myself. Okay, so the first quantity that we're going to find is the dot product between the two vectors. So, So vector v dotted with vector w. So I'm just going to go ahead and rewrite the two vectors over here. Vector v is equal to 2i hat plus 10j hat minus 11k hat and vector w is equal to 2i hat plus 2j hat plus k hat, if I'm correct. Yep. Plus 2j hat plus k hat. K hat. All right. So vector v dotted with vector w. So all you have to do is multiply each individual component of the two vectors together. So 2 times 2 plus 10 times 2 plus negative 11 times 1. And then if you just go ahead and make those multiplications really quick, this is equal to 4, this is equal to 20, that's equal to negative 11, so the dot product is 13. Okay. As for the magnitude of v, take the square root of each component of vector v squared. So 2 squared plus 10 squared plus negative 11 squared, which is equal to the square root of 4 plus 100 plus 121, which is equal to square root of that, square root of 225, which works out nicely to 15. And last but not least, vector w is equal to, or the magnitude of vector w rather, square root of 2 squared plus 2 squared plus 1 squared, which is equal to the square root of 4 plus 4 plus 1, which is equal to square root of 9, which is 3. Okay, so that's part A of that problem. Now part B, we are going to figure out what the cosine of the angle between the two vectors is. So if you remember from your formulas, cosine of the angle between two vectors is equal to vector v dotted with vector w over magnitude v magnitude w. And if you just go ahead and plug in the values that we just obtained, it's equal to 3, oh, sorry, doing the bottom first, 13 over 3 times, or 15 times 3, which is equal to 13 over 45. Next, we're going to want to find the component of w onto v. So if you go ahead and take a look at this problem right here, so we want to find, and I'm just going to go ahead and draw a little illustration. If this is vector v and this is vector w, we want to find this length right here, right? So this angle is equal to theta, and if you remember, cosine is equal to adjacent over hypotenuse. Cosine of the angle between these two the cosine of this angle is equal to this length divided by this length. So cosine of the angle is equal to this length, which is what we want, the component, divided by magnitude v. So then if you go ahead and multiply by magnitude of v on both sides, you get that the magnitude of v times the cosine of the angle is equal to the component of, and I'm just going to go ahead and erase this drawing, the component of, wait a second, let me see, of w onto v. I think I did it backwards. Yeah, I did. My mistake. So, going to go ahead and redo that drawing. Just got the vectors backwards. So, this is vector w, and this is vector v. We want to find this length right here. So based on theta, we know that this component is of vector w onto vector v is equal to the cosine of the angle, or is equal to the magnitude of w times the cosine of the angle between them. And this is because the cosine of the angle between these two vectors is equal to this length, which is the component, divided by the magnitude of w, which is the hypotenuse of this right triangle. So therefore, if you go ahead and, so if you multiply the cosine of the angle by the magnitude of w, you just get this length right here. And if you go back to the original formula, that means, for cosine of theta, that means that the component is equal to vector v dotted with vector w over the magnitude of v. Yeah. So if you go ahead and plug those numbers into the formula really quick, so b dot w is equal to 13, and magnitude of v is equal to 15, and this gives the correct answer. So the component of v onto, or of w onto v is equal to 13 over 15. I'm just going to go ahead and erase what I have now. So that was problem C. I'm just going to go ahead and erase this now, and I'm going to go ahead and solve part D. I'll go ahead and leave that the component is equal to 13 over 15, though, because that is going to be useful. So for part D, we want to find the projection of vector w onto vector v. And all this is a vector with length. Now I'll go ahead and draw an image of it because it makes it a little bit easier to show. So if this is vector w and this is vector v, then the projection of w onto v is this vector right here, starting here and ending here. So it's going to have a magnitude equal to the component of w onto v, and it's going to be in the same direction as v as well. So in order to turn the component into a vector, we need to multiply it by a unit vector in the direction of v. So the first thing we want to do is we want to find the unit vector in the direction of v. And the way we do that is just take the vector v and divide it by the magnitude of v. And this gives the vector 2I hat plus 10, j hat minus 11, k hat over 15. which is just 2/15 I hat plus 10, or 2/3 j hat minus 11/15 k hat. And now, in order to get the correct magnitude, what you have to do is you have to multiply this unit vector by the component of w onto v to give it the correct magnitude. So if I go ahead and do that, I'm going to go ahead and multiply what we just got by 13/15, which is what the component of w onto v is equal to. Divide by 2/15. J hat minus 11/15 k hat, which is equal to 26/225 I hat plus 26/45 j hat minus 13 times 11 is 143 over 225 k hat. And that is the solution to part D, the projection of vector w onto v. So this concludes this particular section for multivariable calculus, the dot product. Again, if you have any questions that you want us to do other than those that are on your worksheets, we'll be more than willing to give them a shot. And thank you very much for your time.